All right, so this video we're going to work on matrix addition, subtraction, and scalar multiplication. We'll do another video on just multiplying matrices together. So we can add and subtract two matrices if the dimensions are the same. So what we mean by that is we have a 2 by 3 matrix here and another 2 by 3 matrix. And so that means I'm allowed to do some adding and subtracting with them. I am not allowed to add a 2 by 3 and a 3 by 2 or a 2 by 3 and a 4 by 3. They have to have the exact same number, they have to have the same dimensions. To find the sum of the difference between the two matrices, we add or subtract. Basically, it's corresponding entries. So, for example, if I'm going to try to add matrix A and B together up above, then what I would do to get to the answer is I would say, okay, in the first cell, I get to do 3 plus 0. Let me try to get a smaller tip here. All right, so let's see if we get it. See if that works better there. So we'd have 3 plus 0. Then in the next spot in the middle row, top row middle, would be 0 plus 2. So 0 plus 2. And then we would do 4 plus a negative 5. So 4 plus a negative 5. And then now we go to the next row, we would say negative 1 plus 9. Then we would have 7 plus a negative 1. And then it would be 2 plus 3. So my final simplify would be my new answer. The sum of the two matrices would be 3, 2, negative 1, 8, 6, and 5. All right, so now subtraction. So with that in mind, to get the first, again, as we do this in stages, we can subtract each corresponding location. So it would be 3 minus 0, 0 minus 2, 4 minus a minus 5, negative 1 minus 9, 7 minus a minus 1, and 2 minus 3. And so my answer would be, in the final matrix, would be 3, negative 2, or 4 minus a minus 5 is positive 9. Negative 1 minus 9 is negative 10. 7 minus a minus 1 is 8. And then I had negative 1. So again, these are my answer matrix right here. All right. Scalar matrix multiplication refers to finding the product of a matrix and a number. In scalar multiplication, multiply each element by the scalar. So typically, the way we see it arranged is we see a coefficient on the matrix letter, or it could be written in the standpoint of like 4, and then whatever's in matrix A, 2, 5, 6, 9, and that would be another way to indicate it. So we can either do 4 times whatever they say the matrix is named as, or we would see actually the 4 in front of the matrix symbol itself, and we would do the same thing. So they ask us to do 4 times matrix A. So we got to go up here and grab matrix A again, which was 3, 0, 4, negative 1, and 7 and 2. So now what I have to do is I have to think about, and I'm going to erase this other one here just to get it out of the way. Now what I have to think about doing is multiplying this 4 into each of the items, each of the elements. So 4 times 3 is 12, 4 times 0 is 0, 4 times 4 is 16. Then we go to the next row, 4 times -1 is -4, 4 times 7 is 28, and 4 times 2 is 8. Again, if you want to pause, you can go ahead and pause and give you a chance to do this one ahead of me. All right, so now on this one, I'm multiplying -1 into each element. So 0 times -1 is 0. -1 times 2 is -2. -1 times -5 is 5. -1 times 9 is -9. -1 times -1 is 1. -1 times 3 is -3. So again, scalar multiplication works pretty nice and short and sweet. They ask us, can you find the sum of matrix A and matrix C? Are you allowed to do that? So we think about it, matrix A was 3, 0, 4, -1, 7, and 2. That was matrix A. There's matrix C. Well, again, matrix A is a 2 by 3. Matrix A. And matrix C is a 3 by 2. So even though they have common numbers there, they don't have the same dimensions. Even though they have the same number of elements, they still don't have the same dimensions. They have to match. These dimensions have to match in that order. So we are not allowed because the dimensions don't match. So now we get to practice. So this is where I would recommend just pausing the video and practicing it. We have some extra practice on that one right there. But again, it's going to take a little bit of time. First thing we got to make sure is, I'm going to label each of these matrices 2 by 3, 2 by 3, 2 by 3, 3 by 2, 3 by 2, 2 by 2, 2 by 2, and this is a 3 by 1, 3 rows, 1 column. And I did that because that way I can, when I see certain things paired up, like I can only combine F and G together. I can only do some type of combining with D and E together. I can only do some combining with A, B, or C, those 3 together. H can't be combined with anybody. So that's why I went ahead and did that. So if we're looking at any adding or subtracting, then we got to make sure we match. Now, the scalar multiplication, we can go ahead and do it to anything. So as I look at A and A plus C, and again, it may help to write them down next to each other. 2, -1, 5, 3, 0, 14. I'm adding to it 0, -2, 3, -5, 11, 4. And then because this ends up being a lot of space being taken up here. 2 plus 0 is 2. -1 plus a -2 is a -3. 5 plus 3 is 8. Next row, 3 plus a -5 is -2. 0 plus 11 is 11. 14 plus 4 is 18. And there is my answer matrix. And then now, this one here, I'm not going to be able to squeeze all of it on there, so I'm going to just do the answers. My answer is going to be a 2 by 3. So it is going to be a 2 by 3 matrix as the answer. And I'm just going to carefully just add up. Okay, 2 plus 6 plus 0 is 8. -1 plus 10 is 9. Plus a -2 would be 7. 5 minus 5 is 0. Plus 3 is 3. And then 3 plus 5 is 8. Minus 5 is 3. 0 minus 1 is -1 plus 11 is 10. And then 14 plus 2 is 16 plus 4 is 20. And that's why the only way I could figure out that one was easier to do that because there's just not a lot of room. Now number 3, D minus E. Do they have the same dimensions? 3 by 2, 3 by 2, yes. So I can go ahead and do this one. Again, I'm gonna do this without, and again, order matters in subtraction. So D first. 1 minus a minus 1 is 2. And then -4 minus a minus 1 would be -4 plus 1, which is -3. And then we would go 7 minus 6 is 1. 2 minus 7 is a -5. 6 minus a minus 2 is 8. -8 minus 10 is -18. Now they ask, can I do C plus D? Can I add these two? And I would say cannot. So cannot be done, CBD. CBD cannot be done. Then they asked me to do E minus D. Okay, I could do E minus D. It's just the opposite order. And what we're learning here is that just like in regular mathematics, subtraction is not cumulative. I can't change the order of what I'm subtracting and get the same answer. Addition is cumulative, and we find this out. One of the properties with matrices is I can't change the order of subtracting matrices and get the same answer. So what does our answer look like? -1 minus 1 would be -2. -1 minus a minus 4 would be +3. 6 minus 7 is a -1. 7 minus 2 is 5. -2 minus 6 is a -8. And then 10 minus a minus 8 is +18. Okay. So now we look at what happened here is by changing the order, basically it was the same numerals, just opposite signs. But again, they're not equal. They're different. So, all right, now they ask us on number 6, do 3 times matrix H. So that's where I get to do 3 times each of the numbers. And so that would be -12, 12, and 3. 2 times G, so 2 times this matrix. So I got to distribute that 2 into everything. So -4, 12, 2, -6. I know I'm going quick, but again, right now it's like it's really easy math. Number 8 gets a little bit more complicated because I have to multiply F by 2 first, then I can add G and F together. So the first thing I gotta do is go up to matrix F and multiply all those elements by 2. So I'm gonna write that down real quick. 18, 0, -6, and 2. And then now I get to add this new matrix to matrix G. So 18 plus a -2 would be 16. 0 plus 6 is 6. And then -6 plus 1 would be -5. And then 2 plus a -3 is -1. So there is my answer matrix. And then this one -H means just multiply -1 to matrix H. So that means it's just going to change all the signs. So my answer will be 4, -4, and -1. And then again, going back to number 10, it says 3 times A, and then I'm supposed to add A and G together. Well, I can multiply 3 times A, so I could get 6, -3, 15, 9, 0, and 42. But then when I look at it, and I go to add it to G, G is -2, 6, 1, -3. And they don't have the same dimensions, so this one cannot be determined. Can't do this one. I can get part of it done, but I can't get the final answer. Using the matrices above, write an expression that would create matrix. Oh, so this one you get to pick up there. I want this to be my final answer, which kind of leads into my next video. And so using the matrix above, write an expression. So obviously I got to use F and G together. And so if I look at F, F is 9, 0, -3, 1. That's F. G is -2, 6, 1, -3. Let's see. Well, 9 minus 2 is 7. 9 minus a minus 2 is 11. That's the opposite that I need. So what if I do -2 minus 9? That's -11. 6 minus 0 is 6. 1 minus a minus 3 is 4. So this in mind, what I need to do is I need to do G minus F. That's the order I need to do. G minus F is equal to my matrix H, my matrix X there. All right, that'd be the end of that video. Again, here's just some more that you get to practice. Again, this one's a little bit different, as I was finding this on the internet to work. And they actually answer each of these questions. It says, in number 1, it says, how many cups of coffee were sold by Moonbucks on Monday? And so what you have to do is, if you read all the problem here, on Monday, let's see, Sunday night, the ending cup count was 843. After the end of Monday, they had 256. So if we subtract those two numbers, 843 minus 256, then I can figure out how many they sold on Monday. And again, you might want to do that one in a calculator. I'm going to try to do it real quick here. 7, that's a 13, that's a 8, that's now a 7. So I think it's 587. How many cups were sold by Mad Cup on Monday? Again, same thing, subtract 580 minus 355. That would be 5. That's now a 7. That's a 2. And didn't need a bar. There you go. So 225. If the two coffee shops were combine their supplies, how many stirrers will they have for Tuesday? All right. Well, we would take both of the ending counts. We would say, okay, let's take 512 plus 175, and that gives me 687. So again, the rest of that you can go ahead and practice, but I just want to give a little bit of start there.